Hello again, this is Ms. Nakayama. Today's lesson is 6.5a, Properties of Logarithms. So, I hope that you spent the time and energy to do that warm-up well, because if you did, as I said, this will be easy. So this is going to be a quick overview of the properties, because you already put the time into that warm-up. So first, we have the product property. Okay, the product property tells you that the log of a product is equal to the sum, and so the key, that's right, I'm going to go this. The log of a product is equal to the sum of the logs. Think about what you do when you multiply with exponents. X squared times x to the third. Remember, the log is the exponent. When I'm multiplying, what do I do to the exponents? I add them, and that's x to the fifth. So that's what this is doing, that same kind of thing. So in a similar fashion, the quotient property, the log of a quotient is equal to the difference of the logs. So if I was doing x to the, I don't do that one. Let's go here. If I did x to the sixth over x squared, what do I do to those exponents? Well, you know that you subtract them. That's x to the fourth. Okay, and last but not least, we have our power property. When I taking the log of a power, that's like multiplying them. So if I had x to the second raised to the third, what do I do to those exponents? I multiply them. So that's what these properties, that's what they're all tied to, each of them. You need to know them because it's a very critical step in solving equations. So today we're just practicing the properties. So look at this. To expand, example 1, expanding a logarithm. So take this and expand it as far as you can. And that means you can't leave anything with an exponent or a radical. So, y'all, you can go through the many steps. And if you look in Delta Math, he'll show you the many steps. But I'm going to tell you a very direct way to do it. And that is, you know how this is either plus or minus? Okay, the deal is if it's in the top, then the log is going to be positive, m, n, and n. In each of these cases, it's positive. If it's in the bottom, it's going to be negative. So I have two factors in the top and one in the bottom, so I know I'm going to have the ln of something plus the ln of something minus the ln of something. So the first factor is ln of 5. The next one is ln of x to the seventh, but that seventh has to be brought down in front with your power property. And then the bottom is y. And that's all you have to do. All right, look at the second one in example 1. So how many factors? I have the log of x over y to the fourth cube root of z. So I have 3 different factors, so I'm going to have 3 terms like I do right here. So, and I'm going to have 1 positive and 2 negative. I promise you it's an easier way to do it than step by step in this case. So log of x is positive minus the log of y to the fourth, but I can't leave that 4. I got to use my power property and move it in front. And then the log of z, and the power would be not 3, but 1/3. And again, I have to put it in front. So that's my answer. Now, that might not be so intuitive, but that's a little bit easier for people to do. But what you have to be able to do is go backwards in solving equations. So if you look at this next one, we have to condense it. So this one we were expanding and making it bigger. Now we are condensing into a single log, y'all. That means your answer can only have the word log one time. Okay, and as I said to you, if the expression is positive, it's going to go on the top. If it's negative, it's going to go on the bottom. But before you bring it all together, you have to just have a word log something. That says 3 log 2, so I have to remember that that 3 becomes the exponent. And then there's nothing here but a log 3. So on the top, it's going to be a 9, and then it's going to be 2 to the third. Okay, well, what does that plus tell me to do? Remember, I add when I multiply, so I'm going to have 9 times 2 to the third, and on the bottom, I'm going to have a 3. So when you multiply 9 times 2 to the third and divide it by 3, you get 24. So this is the log of 24. This, I can't tell you how important this is, y'all, in solving equations. Okay, look at this next one. Condense 2 log base 8 of x minus log base 8 of 5 minus 3 log 8 base y. Again, I'm condensing. I'm going to have only one word log in my answer. Okay? And when I look at each expression, this is 1, 2, 3. I can't have a number in front. I got to remember that number in front becomes my exponent in each case. So positive goes on top. On top, I'm going to have x squared. Anyway, positive have x squared. On the bottom, I'm going to have a 5, and I'm going to have y cubed. And that's all it is. Practice. All right, the last one. Change a base formula. You did this at the end of your warm-up, okay? You can use any base you want. As it says right here, I have the log base c of a. I can use the common log, or I can use the natural log. Well, let's see what happens. If I evaluate log base 3 of 8, okay, that means that is the log base 8. If they and actually the reason I'm doing it this way, y'all, because it says use common logs here. Down here it says use natural logs. So log of 8 divided by the log of 3 is 1.8928. If I use natural logs, ln of 8 divided by ln of 3 is, you guessed it, 1.8928. So this is important to remember. It does not matter which one you use when we get into solving equations. The only reason I use that one is because it's shorter to write. But anyway, practice those properties. They are so, so important. You need to be well versed with them. Thank you so much for watching. Please don't hesitate to email me or come see me if you have any questions. Y'all have a great day.